Good morning, students. This is Vikas Giri, PGT Physics, USCD DAV Public School, Maharajganj. Today, first of all, we are going to discuss the syllabus of Standard 10th Physics. In Physics, we have 5 chapters: Chapter 10, Chapter 11, Chapter 12, Chapter 13, and Chapter 14. Chapter 10 is Light, its reflection and refraction. Chapter number 11 is the human eye and the colorful world. Chapter number 12 is electricity. Chapter number 13 is magnetic effects of electric current. And chapter number 14 is sources of energy. Today we are going to start chapter number 12, that is electricity. In this chapter, first of all, we need to know what electric charge is and what are the properties of electric charge. So, charge is a property of matter. Electric charge is of two types, namely positive charge and negative charge. Electron, you might be knowing, electron is a particle that revolves around the nucleus of an atom in different orbits, and it carries negative charge. Charge on an electron is denoted by QE, and its value is minus 1.6 into 10 to the power minus 19 coulomb. This C is read as coulomb. C is the symbol that we use for coulomb. This negative sign indicates that electron has negative charge, and 1.6 into 10 to the power minus 19 coulomb is the magnitude of charge on an electron. Next, proton is a particle that remains inside the nucleus of an atom, and it carries positive charge. Charge of a proton is denoted by QP. It is positive charge and its magnitude is 1.6 into 10 to the power minus 19 coulomb. It is very clear that the magnitude of charge on an electron is equal to the magnitude of charge on a proton. An electron and a proton have equal magnitudes of charges. The only difference is that charges are of opposite nature. Electron has negative charge while proton has positive charge. Otherwise, the magnitude of charges on these two particles are same. Now, next point is, substances usually are electrically neutral. Now, if a few electrons are removed from a substance, the substance becomes positively charged. On the other hand, if a few electrons are added to a substance, the substance becomes negatively charged. Simply, removal of electrons from a body produces positive charge on the body, whereas addition of few electrons to a body produces negative charge on the body. Now, the first topic of this chapter is electric current. Electric current is denoted by I. This I may be small, may be capital. Here I have used small I to represent electric current. Now, what is electric current? When do we say that electric current is flowing through a conductor, and how is it measured? What is the formula for the measurement of electric current? So, the flow of charges through a cross-section of a conductor constitutes electric current. Whenever there is flow of charges through a cross-section of a conductor, cross-section means a portion of conductor. Whenever there is flow of charges through a cross-section of a conductor, we say electric current is flowing through that conductor. And its definition is mathematical definition. So, electric current is defined as the rate of flow of charges through the cross-section of a conductor. The rate of flow of charges through the cross-section of a conductor is called electric current. Now, question arises, what is meant by rate of flow of charges? The rate of flow of charges means the amount of charge flowing per unit time or in 1 second. The amount of charge flowing in 1 second is called rate of flow of charges, or you can say the amount of charge flowing per unit time is called rate of flow of charges. So when do we say that electric current is flowing through a conductor? The answer is when there is flow of charges through a cross section of a conductor, then we say that there is flow of electric current. There is flow of electricity through the conductor. And what is the proper definition of electric current in physics? So electric current is defined as the rate of flow of charges through a cross section of a conductor. In other words, you can say the amount of charge flowing per unit time through a cross section of a conductor is called electric current. Now, here we have a conductor and we have considered a cross section of a conductor through which charge Q. Q is used to denote charge flowing through the cross section of the conductor. Suppose here we have a conductor and it's a cross section of a conductor through which Q charge flows in time t. Here I have written, if Q be the charge flowing through a cross section of a conductor in time t, then electric current is given by I equal to Q by T. That is, electric current is equal to charge by time. So this is the formula for electric current. Using this formula we can calculate electric current, how much current is flowing through a conductor. Q equal to IT, this is equation number 2. Now, SI unit of electric current. We have formula for electric current as electric current equal to electric charge divided by time. Now, the SI unit of electric charge is Coulomb and the SI unit of time is second. So, the SI unit of electric current becomes Coulomb per second. And this Coulomb per second is called ampere. So, the SI unit of current is Coulomb per second and is called ampere. So, we can write 1 ampere equal to 1 Coulomb upon 1 second. Symbolically, ampere is denoted by capital A, Coulomb is denoted by capital C, and second is denoted by a small s. So, if we want to write this expression 1 ampere equal to 1 Coulomb divided by 1 second symbolically, then we will write 1A equal to 1C divided by 1S. In our next video lecture, we will be discussing definition of ampere, that is definition of SI unit of electric current, direction of flow of electric current, ammeter, and a few numericals based on the formula of current. Thank you.